Thank you for supporting CMA Math Academy. If you're watching on YouTube, don't forget to like, comment, and subscribe for more great CMA math content. Okay, so you should have your foldable set up like this, and the first thing that we are going to write down is this information in our top left box. So all this information is going in the top left box. So I'm going to give you a second to write. This is kind of like our title page, some information about our foldable, and then we're going to look through 3 examples before you get some practice on your own. So I'll give you a second to write this down. Okay, so now that you've had a chance to write, let's talk about what it's saying. So if you remember back to yesterday, the basics are really what we've talked about yesterday. So you're going to help me out when I stop, you read the next word. So we're on the first bullet, you guys got the next word. So it says at least 2. So remember we talked about yesterday, to be a system of equations, it has to have at least 2 equations. So 1 equation is just an equation. 2 equations, 3 equations, 4 equations becomes a system of equations. So we have more than 1. Okay, let's go to the second bullet. Again, everybody helping out. So it says each needs to be in slope intercept, and again, that's y equals mx plus b. So if it's not written like that, you have to convert it into slope intercept form, and we practiced that in block 2 yesterday on one of our stations. You had a graph that you had to do that. You had to convert it. Okay, let's look at the last one. Again, you help me out. It says graph them to find the, so you just graph them, and that will tell you all the information you need. So we talked about this yesterday in my group, is the graph is not the answer. The graph is the work. You use the graph to get the answer or the solution. Okay, and we'll talk about how we want to write that answer, go back over that a little bit. All right, so that's at the top left box. Let's move to the top right box. Okay, so if you'll notice as you're writing, my equal signs are lined up. So as we go through our foldable, every time we write a system of equation down, you have to line up the equal sign. It doesn't matter as much for graphing, but it really matters when we get into the other ways of solving, which is substitution and elimination. So you want to line those up. Okay, so I'm going to give you a second. We've done this stuff before, so I'm going to give you a few minutes, and I just want you to try and work these and put them on the graph. So the first equation's already done for you. You can graph that. It's in slope-intercept form. The second equation you're going to have to transform into slope-intercept form and then put that one on the graph. So I'm going to give you a couple minutes here. Let's see what you got. Ready, go. Okay, so now that you've had a chance to work, let's check our work. So in our first equation, y equals 4x plus 3, remember that plus 3 is our y-intercept, so we go up 3 on the y-axis, and that's where your first point should have been. Then the slope, this positive 4, tells us how to move. Now remember, since it's just positive 4, we put a 1 underneath it. So if it's 4 over 1, that's up 4, right 1. But if you'll notice, if I go up 4, whoop, I'm off the graph. So we can go right into going down 4 and left 1. So go the opposite. So instead of up 4, right 1, you're going to go down 4 and left 1. Okay? Down 4 and left 1. Now we actually have enough room. We could have put another point, down 4 again, and left 1. And we'd have a point down here. So then we should have connected. Now we talked about this yesterday. Remember, with these, it's very, very, very important that you make your line really accurately and that it goes all the way through your graph. So it has to be very precise on your line and make sure you go through all those points. Let's look at the second equation. Again, this one was not written in slope-intercept form. You had to do some work to get it into slope-intercept form. So remember, we want y all by itself. So that tells me that this 4 needs to move and the 4x needs to move. If you're ever having trouble with this, just remember, move the x first. Move the x first. So our x is positive, which tells me I need to subtract 4x from both sides. Now I can't subtract 4x from 8, so I just write it next to it. So what I have left is 4y, because this is gone, equals negative 8 minus 4x. Then the next thing I'd look at is I have a 4 next to the y. This is a coefficient. So to get rid of the coefficient, that's multiplication. The inverse of multiply is divide. So I'm going to divide every single one of these by 4. So every term gets divided by 4, which leaves me with, these 4's cancel out, y equals, because you guys are going to help me on the right side. So everybody, what's negative 8 divided by 4? So we should have said negative 2. And again, you're going to help me. What's negative 4 divided by 4? Should have had negative 1. That leaves us with negative 1x. Our final step is we have to switch these around. Remember, when we switch them, everything goes with it. So the signs also move. So that negative that's in front of the 1x moves to the front, and then we just slide everything back. So it's saying y equals negative 1x minus 2. And then we should have graphed this graph. So again, the negative 2 tells us where we're starting at. So here's negative 2. If my slope is negative 1, that's really negative 1 over 1. Remember, the negative sign only applies to the numerator in the top. So this is down and to the right. So I'm moving down 1, right 1. And then I want to come back to my original point and do the opposite. So the opposite of down is up, and the opposite of right is left, and I have my next point. Now you can already kind of see this, but when I connect my line through, you'll see that my lines actually intersect. This is the important part. Remember, as I was saying, your graph is the work. What you get from your graph is the answer. So your answer is this place right here where they intersect. Okay? So over to the right, you're going to have a point for your answer. So you need to give me an ordered pair. So you're going to tell me real quick, where is this point located on our graph? And you're going to write that in your paper. So go ahead and do that. So on 3, we're going to say where that point is located. Okay, ready? 1, 2, 3. And we should have said negative 1, negative 1. Now here's the other important thing. We've talked about the different types of solutions, which is one solution, no solution, and many solutions. If they cross each other, we talked about this yesterday in our groups, this is a one solution answer. So if there's a point where they cross each other, makes an X. So think about it that way. If your graph makes an X, this is a one solution answer. And the answer, or the solution, is this point that we found. So what that's saying is if I went back to my original, so I'm going to erase a little so we can see this just a little bit better. So I'm going to erase. Okay, so if I went back to these original equations and I took my answer, negative 1, and I subbed it back in, it would make our equations true. That's what it's saying, and that's the only one. There's only one answer that would make it true. That's what one solution means. Okay, so with that said, I want you to move down to your bottom left box, and I'm going to give you a second to write this equation down. Remember, we want to have our equal signs lined up. After you've written this equation, I'm going to give you a few minutes, and I want you to graph both of these, see what this graph looks like. Okay, so you're writing it and then working it out. Ready, go. All right, so let's check our work. So we're going to do the first equation, and that's the one that's not in slope-intercept form. So to make it easier for me, I'm going to rewrite it down below. So it said 6y plus 4x equals 6, and I'm just doing this to give myself some more room. Okay, so we're going to go ahead and work this out. Remember, our goal is to get that y by itself, so that tells me the 6 needs to move, and so does the x. Remember what I talked about a second ago, move the x first. So this x is a positive x. So the inverse of plus, we know the inverse of addition. Everybody, what's the inverse of addition? So we're going to subtract 4x to move it to the other side. So that'll cancel out my 4 that's on the left side. Okay? So I'm left with, so I bring this down to kind of regroup, 6y equals 6 minus 4x. Again, I have a coefficient of 6 right here. So we know that if it's multiplication, everybody, again, what's the inverse of multiply? Should be division. So we're going to divide everything by 6. Okay, so these 6's cancel out, and I'm left with y equals. You guys help me out. What's 6 divided by 6? So I have positive 1. Now on the negative 4 over 6, if we divide that out, you get a repeating decimal, and we don't want that. So we're just going to reduce it. So I know for 6, I can divide both of those by 2, and that's going to reduce down to negative 2/3 x. Finally, your last step is just to switch our two values. Now remember, you have to keep things, the sign needs to stay with it. So this negative sign stays with the negative 2/3. So negative 2/3 x. And since 1 is positive, it was plus 1. So here's the first equation we are graphing. So our first point should be at positive 1 because that's our y-intercept. If it's a negative fraction, remember the minus sign, the negative only applies to the numerator. So it should have been down 2 and right 3. And then to get my other point, I'm going to do the opposite, up 2, left 3. And I get a line that goes through my graph that looks like this. Okay? So then I needed to graph my second equation, which was already in slope-intercept form. And that's negative 3 as the y-intercept. So I'd come down here to negative 3. And it has, again, negative 2/3 as the slope. So I'm going down 2 right 3. I'm going up 2, left 3. And I'm going to connect those 3 points. And I'm going to connect those 3 points. Okay, so I get this line here. Now, I want you to notice something. I want you to talk to your neighbor for 1 second here and see if there's anything weird you notice about this graph compared to our other graphs. Okay, so go ahead and talk it over. All right, so hopefully you notice, first of all, that these 2 lines don't run into each other. They don't touch. And in fact, these are parallel lines. Okay, now I want you to think about in our equations, we had a slope of negative 2/3 in one of our equations. And in the second equation, we had a slope of negative 2/3. So anytime you have the same slope, so we're going to write this down. So I'm going to write this down below here. So same slope equals parallel lines. Okay, so these 2 lines mean parallel. Remember, parallel means they're going to go on and never touch, same distance apart. Okay, if we have parallel lines, then the answer or the solution is there is no solution. They never cross. So if they're the same slope, parallel lines, they never cross, then our answer is no solution. So no matter what number we put in there, there's never going to be a right answer. This is a no solution answer. So same slope, parallel lines, no solution. Okay, so now that one's done, let's go to our last box. Okay, so here's our bottom right box. I'm going to give you a second. Go ahead and write this down in the bottom right box. Remember to line up your equal sign. And I'm going to give you a few minutes again to work. And then once you're done working, we'll check how we did. So go ahead and try and solve these and put them on the graph. All right, so hopefully you've had some time to work, and hopefully as you were doing this, you realized something weird happens. So let's look what I'm talking about. So the first equation is very straightforward set up for you. So it's already in slope-intercept form with our y-intercept being positive 4. So our first point had to be at positive 4. And then our slope is negative 1/2. Remember, the negative sign only goes with the numerator. So it's down 1 and right 2. And then I do the opposite, and I go back to where I started, up 1, left 2, and I get my line for the first equation. All right, so there's my line for my first equation. Let's look at the second equation. So I have negative 8 plus 2y equals negative x. So again, we've talked about we usually want to move the x first. Well, in this case, we don't really want to because x is already on the right side. Instead, we need to move negative 8 first. Then we'll come back here and move the 2. So help me out. The inverse of subtracting 8 is, so if we said adding 8, or addition. So I'm going to add 8 to both sides. Okay. Then after I'm done with that, I'm going to go ahead and divide everything by 2. So it kind of gets a little weird here because the 2's cancel out. So I have y equals, but then I have negative x over 2, which is weird. But if you remember, if I have a variable by itself, that's really a 1. So this is really negative 1 over 2x. So it kind of changes into 1/2, and we're going to leave it like that. Plus, and then 8 divided by 2 is 4. So we're going to go ahead and graph this equation. Now, hopefully you notice this, but I want you to talk it over with your table partner. I'm going to stop right here and just see if you notice something about our equations now. So I'm going to give you a second, talk it over. Okay, so hopefully you noticed that our equations were literally the exact same. So these 2 equations were the exact same equation, okay, once we rearrange it into slope-intercept form. These became the same, okay? So if I graph my second equation over on the graph, it's going to give me the exact same line that I already have. So if I put my first point, it's going to be at positive 4. Then I would move down 1, right 2. Then I'd move up 1, left 2. And it's the exact same line. So let's write this down in this box. This is the important takeaway from this box. If you end up with the exact, now it has to be exactly the same. So if it's exactly the same equation, that means it's going to be the exact same line. Okay? If it's the exact same equation, the exact same line, that tells me there are infinitely many solutions. Okay? So my answer would be infinitely many solutions. So All right, so hopefully you have a better understanding of graphing systems of equations from our foldable now. On the back, so I don't care where you write it, one of the boxes on the back, I need you to summarize. So in your own words, so I want to know what you know, how do you solve a system of equation by graphing? So just explain the steps. And we kind of wrote that in the first box, so if you need to reflect back to that, you can. And then what do the different types of solutions look like on the graph? So how do you know if it's one solution or no solution or many solutions? What do the graphs look like? These are complete sentences, and then after this we have some practice on our own. All right, great job, guys.